Mr. Haywood changes US $50 to Jamaican dollars at a rate of US $1 to Jamaican $70. How much did he get in Jamaican currency? For most students, the solution to this problem is pretty much straightforward. Because of the experience that we generally have changing money, we inevitably do the correct thing. However, a logical argument may be developed while solving this problem. According to how the rate is given, US $1 is equivalent to Jamaican $70. The figure on the Jamaican side, which is 70, what we have right here, is larger than the figure on the US side, which is $1, which is 1. Therefore, during the conversion, we expect US to Jamaican will give a larger figure. So if we are going from this side to this side, we are going to be moving from a small value to a larger value. In figure, that is, the number on the Jamaican side will be larger. In order to get a larger figure, we multiply the number in the rate by the amount of money that is to be exchanged. Therefore, we are converting US $50 to Jamaican. The US side, the number here is 1, which is smaller than the number that we have on the Jamaican side. Therefore, when we are converting 50 from the US side to the Jamaican side, we are going to get a larger number. Therefore, we will be expected to multiply by the number in the rate. So in order to get a larger figure, we will multiply by the number that we have in the rate. So we are multiplying 50, which is the amount that we are converting, by the number that is in the rate, and our answer is $3,500. The answer is option D. Ratio will now be used in solving the problem. US currency will go on the left and Jamaican currency will go on the right. So US $1 is equivalent to Jamaican $70. The ratio is 1 to 70. So then, on this side of the ratio, always we have the US currency, or the value that represents the US currency, and on the right hand side we are always going to have the value that represents the Jamaican currency. We know the amount in US currency, that is the amount that we are going to be changing over or exchanging over to the Jamaican currency, and that is 50. But we do not know the amount in Jamaican currency. So let us refer to the amount that we do not know as X. In the ratio, 50 is on the left and the unknown amount X is on the right. Why is this so? Because we are trying to always put the value that represents the US, or the amount in US dollars, on the left hand side of the ratio, and the amount that represents the Jamaican on the right hand side. But in this case, we know that we are converting $50 US, but we do not know the amount in the Jamaican currency, and we have the ratio in the same order: US first, Jamaican next. So let us design a cross multiplication and equate the results of the diagonals. So we have 1 multiplied by X, and that is 1X, which is X, and 50 multiplied by 70 will give us 3,500. The correct answer is therefore option D. What is 1,500 meters as kilometers. First, we need to recall the relationship between kilometers and meter. 1,000 meters is equal to 1 kilometer. Notice that in the relationship, the figure accompanying meter is larger than the figure accompanying kilometer. So we have 1,000 meter is equal to 1 kilometer. Now we have here meters to be converted to kilometers. Because of this fact that in the relationship, the number on the side of the equation that we have meter is smaller than the number on the side that we have kilometer. When we do our conversion from meter to kilometer, we are always going to get a smaller number. If we are converting to kilometer, the figure that we will arrive at must be smaller than the figure in meter that we started out with. We will achieve this by dividing the figure by 1,000. And of course, 1,000 is the figure that is in the relationship between meter and kilometer. So let us divide 1,500 by 1,000. When solving a problem, if possible, reduce it to a more manageable form. The division is placed in a fractional form for this purpose. So in this particular case, we are dividing 1,500 by 1,000, and we are writing our expression in a fractional form, because by so doing, we will be able to progress very much quicker than if we were to use a long division or so. Now, we may reduce the fraction by a common factor of 100. This may be achieved by striking off 2 zeros in both the denominator and numerator. So, a short way to reduce something by a factor of 100 is to strike 2 zeros in the numerator and 2 zeros in the denominator. We are going to be dividing 15 by 10. This may be done by reducing 15 by 1 place of decimal. The correct answer is therefore option A. The relationship between meter and kilometer may be written as a ratio in order that ratio may be used to solve the problem. So 1,000 meter is equal to 1 kilometer. The ratio that we will use is 1,000 to 1. That's our ratio. We need to know what 1,500 or 1,500 meter is equal to in meters. So let us call the unknown number of kilometers x and write the relationship in another ratio with the number of meters going first as usual. So we are going to write another ratio. This is the number of meters, this is the number of kilometers. And we are writing another ratio with meters going first and then kilometers. The fact is 1,500 meters is what we know. Meters on the left hand side, we do not know the number of kilometers. That will go on the right hand side, because kilometers will consistently be in this problem on the right hand side. So let us design a cross multiplication and equate the results of the diagonals, which is, of course, this one is 1,000 multiplied by x, which is 1,000x, and the other diagonal is 1,500 multiplied by 1. So we have 1,000x is equal to 1,500. X is being multiplied. Of course, we have a simple equation. So we have 1,000x is equal to 1,500 or 1,500. Now we are going to solve this equation by transposing this 1,000 that we have here to the other side, in order that we might get x all by itself on the left hand side. By so doing, we are going to do the opposite of the operation that we have here. the operation that we have here, 1000x, means 1000 multiplied by x. Therefore, in order to transpose this to the right hand side, we will do the opposite of multiplication, which is division. So we will divide the right hand side, which is 1500, by 1000. And our result is x is equal to 1.5. There's no need to go through the details of arriving at 1.5 because that calculation we have done in the first attempt at the question. The correct answer is option A. Which line represents the radius of the circle? What do we call a radius? A radius of a circle is any line that goes from the center of the circle to the circumference. And of course, the circumference is this curved line that goes all around and is closed. So this is our circumference. So the radius is any line that goes from the center to any point on the circumference. Any point on the circumference. So let's look at the first one, AC. AC goes from a point on the circumference to another point on the circumference. Circumference to circumference. That's not a radius. OB. OB goes from the center to the circumference. The line OB goes from the center of the circle to a point on its circumference. This is our correct option. So this line is a radius of the circle. We are going to take a look at the other options. AB, the line goes from A all the way to B. That is the line that we are talking about. AB is not a radius because it goes from one point on the circumference to another point on the circumference. A line that goes from one point on the circumference to another point on the circumference is called a chord. AB is a special chord that goes through the center of the circle and is therefore called a diameter. So the chord that goes from one point on the circumference to another point on the circumference passes through the center of the circle. That chord is a diameter of the circle. BC, which is the one that we have in option D, BC is not a radius because it does not go from the circumference of the circle to the center. Where does it go? From a point on the circumference to another point on the circumference. It is also a chord, not a radius. What is 3,250 milliliters as liters? First, we need to recall the relationship between liter and milliliter. Here we have it. 1000 milliliter is equal to 1 liter. Notice that in the relationship, the figure accompanying milliliter is larger than the figure accompanying liter. If we are converting to liter, the figure that we will arrive at must be smaller than the figure in milliliter that we have started out with. We will achieve this by dividing by 1000, and the 1000 is the figure that is in the relationship between liter and milliliter. When solving a problem, examine the figures for clues of the most convenient method to be used to solve it. Dividing by 1000, as we know, may be easily done by reducing the dividend by 3 decimal places. The 0 at the end may be discarded. The correct answer is option C. We could have used ratios in solving the problem, but the demonstration at this stage is unnecessary, having gone through so many examples. Well, Jerry would have been bored to death if I would use ratio to solve this problem again. Sure you would, Jerry. A clock shows 9:20 p.m. now. What time will it show 3/4 of an hour later? This problem may be solved by using a number of different approaches. We are going to make use of two of them. So we are going to take note that 3/4 of an hour is equal to 45 minutes. So let us forward the clock by 45 minutes, moving by 5 minutes each time. So that is what we are going to do. Take note that a 3/4 of an hour is 45 minutes. We are going to cause the position or the present position of the minute hand to be our 0-minute mark, because we are going to be counting all the way around the clock for 45 minutes, and we are going to begin at the present position of the minute hand. So let us begin at the 20-minute mark and call that position 0 minute. And let us count. Jerry always misses out on the opportunity to count because he's down there picking his fingernails sometimes. So let's go again, Jerry. We are at 0, so counting 5 minutes each time. We have 5, 10, 15, 20, 25, 30, 35, 40, 45. Right, so that is where 45 minutes will take us. So the new position of the minute hand will be at the 5-minute mark. That's where it's going to be. The minute hand has passed 12. The hour hand must advance beyond another hour mark. The minute hand did not pass 12 by much, therefore the hour hand must hardly appear to have gone past the other hour, which is 10. Right, so because this minute hand would have passed 12, it means that the hour hand would have passed another hour mark. But because we know that it did not pass the hour by much, this is 5 minutes, it's passing the hour by 5 minutes, the hour hand will appear to barely have passed 10. The time is therefore 10:05. Jerry, I'm not going to be in the habit of saying 10:05 because the figure that we have there is not an O, it is a 0. So we're going to say 5 minutes past 10 or 10:05. We started with PM. The answer will be definitely PM. Time on the 12-hour clock will only change between AM and PM when our hour hand goes past 12. So if we started PM, we will what? End up at PM, because we do not change from AM to PM or from PM to AM unless this hour hand would have passed 12, and it did not, so we are sure that our answer is also PM. The correct answer is option C. We may find the answer by adding the period of 45 minutes to the instant in time of 9:20. So we are going to add the 45 minutes to the period of 9:20. So we are going to put a 0 right here as a placeholder in the hour column. So 0 hour and 45 minutes. Adding the minutes, we get 20 plus 45 is equal to 65. Not very good, Jerry. This 65 that we have in the minute column is just ridiculous, right? Right. Why? This 65 minutes is more than 60 minutes, and of course 60 minutes is equal to 1 hour. So we divide 65 by 60, and when we do that, 65 divided by 60 is equal to 1. And the remainder is 5. So we have 1 hour and the remainder is 5 minutes. So what do? We write down the 5 in the minute column and carry the 1 to the hour column. In the hour column, 9 plus 1 is equal to 10. That's what we have right there. Good, Jerry. The time sought after in the statement of the question is 10:05 or 5 minutes past 10. So let us see how 65 divided by 60 is equal to 1 and remainder 5. So we'll begin by saying 60 into 65 is 1, and then we say 1 multiplied by 60, 1 multiplied by 60 is equal to 60. And that we will subtract from 65. And the result is 5. And that is how we arrive at 1 hour and 5 minutes, or 1 and remainder 5. 5 will therefore be the remainder. What is 20 centimeters and 4 meters written in meters? We have centimeter and meter, and our answer is required to be in meter. We will therefore convert the length that is given in centimeter to meter. And what is the rate of conversion? 100 centimeter is equal to 1 meter. The figure accompanying the centimeter is larger. When converting from centimeter to meter, we will get a smaller figure. See, centimeters going over to the meter side, the value is smaller. So if we are converting from centimeter to meter, the figure that we'll get will be a smaller. So how do we get a smaller figure? We need to divide 20 by, which is the 20 centimeters that we have here, by 100 in order to get a smaller figure in meter. In doing this, we will reduce 20 by 2 decimal places. We will now add 0.2 to 4. And this is the problem that we have, because we are going to put the 4 down and then put the 2 under the 4. And we are going to make a lovely meal of the problem. So Jerry, I will take your suggestion right now. Very good. Jerry is saying that we have to prepare for adding the decimal 0.2 by causing 4 to be a number with a decimal point also. Alright, let's see what the instruction says. 4 is a whole number. The point is considered to be to its right. Because it's a whole number, the point is to its right. So let us show the position of the point and a place holding 0 as a single decimal place. So we're going to have a decimal place, 1 decimal place here. Just like in 0.2 we have 1 place of decimal, we are going to show 1 place of decimal. And that 1 place of decimal will be occupied by a place holding 0, and that is going to be enough. 0.2 will take its position with the points aligned vertically below each other. That's how we do it. And we are going to add 0 plus 2 is 2. And not to leave the point out, we put the point vertically below the others, and we say 0 plus 4 is 4. So our answer is 4.2, and this is represented by option C. Here's the clock again, Jerry. What do you imagine that we will do this time? The clock shows the time of arrival of an airplane. It arrived 40 minutes before the scheduled time. What is the scheduled time? The plane arrived before schedule. So let us say that it arrived earlier than scheduled. The time that we need to determine will be later that we have on the clock. So, if we are looking at a time that is later, we will have to forward the clock. So the time is actually 40 minutes later. We will therefore advance the clock by 40 minutes, 5 minutes at a time. And we are going to look at the present position of the minute hand, and we call that our 0 mark. And then what do we do after? We are going to advance 5 minutes each time. It is counting time, Jerry. Let's go. 5, 10, 15, 20, 25, 30, 35, 40. The new position of the minute hand will be at the 55-minute mark. That is where we have counted to 40, right there. So the new position of the minute hand will be right there. The minute hand did not pass 12. However, the hour hand must advance to a time that is much closer to the 2-hour mark. Now look at this. Although, as a matter of fact, because the minute hand did not pass 12, we are sure that the hour hand will not go past 2. So we're not going to advance beyond another hour because we did not advance past 12 with the minute hand. However, notice how close to 12 this minute hand is. Therefore, we will have to advance this hour hand to a time that is closer to the 2-hour mark. That's very nice. The time is therefore 1:55, and it is represented by option C. We may find the answer by adding the period of 40 minutes to the instant in time, which is 1 hour and 15 minutes, or 1:15. And of course, a 0 is going to be placed in the hour column because we have only 40 minutes and no hour. So let us add. 15 plus 40 is equal to 55. And 1 plus 0 is equal to 1. It is as easy as that. We did not have a number greater than 60, so we will not have an additional hour to come from the minute side. The time sought for in the statement of the question is 1:55. What is the difference between 34.79 meter cubed and 9.8 meter cubed? The difference between the numbers is the result of subtracting one from the other. Right, so because difference in arithmetic means that we will have to find the result of subtraction, we are going to subtract one number from the other. So let us therefore subtract the smaller number from the larger by first writing down 34.79. Let us then write down 9.8 in such a way that the decimal point, just hold on a bit, Jerry. Let me just write this number down and then I'll be able to answer your question. So let us write down 9.8 in such a way that the decimal points are aligned vertically, one below the other. That's it. Just for cosmetic purposes, let us include a place holding 0 and get set to start our arithmetic process. Yes, Jerry? Okay. Oh, Jerry is saying that because we have 34.79 meter cubed, we need to put the meter cube here. And therefore, we would need to put the meter cube here also. We don't have to do that, Jerry. When working out a mathematical problem, it is very important that we keep the units in mind. We may carry out any arithmetic process that we are doing without including the units. But when writing our answer, the units have to be included if the units are necessary. So we are going to subtract 0 from 9. We cannot do that. Can we, Jerry? Oh, yeah, Jerry is saying yes, we can. Yes, it is that we cannot subtract 9 from 0, but we can subtract 0 from 9. So, 9 minus 0 is actually equal to 9. 7 minus 8, can we do that? Okay, we cannot do that this time. So what do? We go over to the other digit and borrow. Well, in these modern days, Jerry, they don't say borrow anymore. They say rename. Because when you borrow something, you have to give it back. Although people generally borrow these days and don't give back. But the word borrow means that you will have to give back, right? Okay, so we are not going to be giving back. So we are going to rename this figure. So how do we do that? We will take 1 unit from here and we'll be left with 3. But by going to a less significant digit, the value of the one that we are taking from here will be 10 times the value that we have in this column. Therefore, we have now 17, from which we are going to take 8. So we're going to say 8 from 17, and what does that give? 9. Okay, right there. And what next? Do we move over and start to say 9 from 3? Okay, Jerry, we need to put the decimal point also. So let us put the decimal point, and that decimal point will be vertically below the other points that we have there already. Very nice, Jerry. So we're going to say now 3 minus 9, and that is 6. Is it, Jerry? Okay, that shows that you are paying attention. So 3 minus 9 is not possible. So we move to the more significant digit and we rename that. So we are going to take 1 from this 3 and we have 2. And the 1 is taken to the less significant position where it is equal to what? 10 times its value. So we have what? 9 to be subtracted from 13. And the result is 4. There's nothing to be subtracted from 2 that we have right here. Nothing to be subtracted there. So 2 goes right back. The meter cube has to be included as a part of the answer, and the correct option is C, 24.99 meter cube. Yes, Jerry. Yes, it goes to show how important it is to include it. Oh, okay, good. Yeah, he's saying that some people may not remember to include the unit at the end and instead choose option D. That is so true, Jerry. And not also in a multiple choice exam, but in a written paper, some students will write down the wrong units, and wrong units mean wrong answer, and sometimes they do not include any unit at all. And that means the answer is not correct. So it is very important. Oh, Jerry is saying that we could have written the units down in order that we do not forget them. Okay? Well, that is a very good tip, Jerry. Haile Gabriel Selassie ran in the 3,000 meter race, then the 5,000 meter race, which will give the total distance that he ran in kilometers. So 3,000 meter race, 5,000 meter race. 1,000 meter is equal to 1 kilometer. In the relationship, the number accompanying kilometer is smaller. Therefore, in converting from meter to kilometer, the value in the answer will be smaller. We will get the smaller number by dividing 1,000 in the end. So we are going to be dividing by 1,000. When we have found the total number of meters ran, then we will divide that by 1,000 in the end. So which one? The only option that has the result divided by 1000 is C. This is the one that has a division by 1000. This represents our correct answer. So, right. It is pointless in this particular case to emphasize the addition of 5000 and 3000. As a matter of fact, it is present in all the options. So in all the options we have 3000 plus 5000, 3000 plus 5000, 3000 plus 5000. Therefore, the only difference is what we do at the end, which is the division by 1000, and that is what we really need to do in order to get the distance traveled in kilometers. Which will give the area of a triangle whose base is 40 meters and height 25 meters. The formula for area of a triangle is given by area is equal to half base times height. Or we may write it as base multiplied by height divided by 2. Now we could look at this stage and identify this as the correct answer because this is the only one that has anything being divided by 2. The base is 40 meters and the height is 25 meters. Substitute the values into the equation. So where the base is, we are going to have 40. Where the height is, we are going to have 25. Very good. The correct option is A. We could have taken a look at any of the versions and observed that the correct answer would have some denominator of 2. However, the format of the second version that was presented makes it more obvious. So earlier on, we could have looked and said, okay, we have a half. This one is the one that has something divided by 2. But when we have it presented in this way, this looks exactly like this. So we are sure that our answer is option A. For which polygon should we use the formula L plus W multiplied by 2 to find its perimeter? The formula that is given is for the perimeter of a rectangle. With this fact, the question may be written as, how may it be written, which polygon is a rectangle? Because the formula is the one that pertains to a rectangle. So which polygon is a rectangle? The rectangle is option B, and this represents our correct answer. The following table shows the amount of time Mario spent studying mathematics on certain days of the week. How much time did Mario spend studying mathematics on Monday, Wednesday, and Thursday? Yes, Jerry, you can make all the fun that you want. If this table represented your study timetable for mathematics for the week, you would only have periods of half an hour in the time slots, right? Or 15 minutes, a quarter of an hour. I know you, Jerry, you just like to play football. Okay, Jerry. Right. The fact that you're answering some of the questions correctly would be a strong indication that you spend more time studying than half an hour each time, right? Very good. So in order to find the time that Mario spent studying, let us add the times associated with those days. So for Monday, Wednesday, and Thursday, we are going to add those times. So notice that we have whole number, mixed number, mixed number. So we are going to use a strategy to add them very quickly. So let us add the whole numbers first. What are the whole numbers? 2, 2, 1. So that gives 2 plus 2 plus 1, 5 hours. Then what do? We add the fractions. So there are fractions there. We don't have a fraction in this one. We have a quarter and 3 quarters. So we're going to add those fractions. A quarter plus 3 quarter, same denominator, so add the numerators. We have 4 quarters, and 4 quarter is equal to 1. So we have 1 whole hour right here. So the total time is the 5 hours with the 1 hour that we have right here, 6 hours. And this is represented by option D. To determine any fraction of the total time, we need to find the total time. The problem is asking, what fraction of the total time did he spend on Tuesday and Friday? We already know the sum of the time for 3 of the days. So let us find the sum of the time for the other 2 days. So we are talking about the other 2 days, Tuesday and Friday. So we are going to find, of course, if we are going to try to find the fraction of the total time, we are going to find the total time. But we have the time for 3 of the days already. So we need to determine the time for the other 2 days. And we have them indicated right here. So an hour and a half each time. If we add those together, we get 3 hours. The sum of the times for the other 3 days, as determined from the previous slide, is 6 hours. So we are going to add those 3 hours with those 6 hours, and the total time will show to be 9 hours. The sum of the times for Tuesday and Friday is 3 hours. The total time is 9 hours. So for Tuesday and Friday, the fraction of the total time will be represented by what? 3 over 9. And of course, the fraction may be reduced by a common factor of 3. Right. And we have 1/3. And the correct answer is option B. The area of the figure is 100 centimeters cubed. What is the area of the triangle marked A? We do not have enough information to calculate the area of the triangle directly. The area of a triangle is given by what, Jerry? Wake up. What? Half base times height. No, Jerry, I know that you were not sleeping. But when I say wake up, I'm trying to call your attention to the problem. Not that I'm trying to wake you up from your sleep, but it's just to alert you to the fact that I need some assistance with this problem. Okay. All right, Jerry. All right. Good. Very good. As we know, the area of a triangle is half base times height. Here we will have the base of a triangle, but we do not have the height. However, we have the total area, and we are able to find the area of the triangle. So we have the total area of the figure, and we need to find the area of the triangle, and of course, we can find the area of the rectangle. So, what do we say? The area of a rectangle is given by area is equal to length times width. The length is 10 centimeters, and the width is 7 centimeters, as we have here, 10 by 7. So the area will turn out to be 70 centimeters squared. We know the area of the entire figure, and we know the area of the rectangle. The area of the triangle is the difference between the two of them. So we are going to subtract the area that we have found for the rectangle from the area of the entire figure, and we are going to find the area of the triangle to be 100 minus 70, and that is equal to 30 centimeters squared. Yes, Jerry, it is perfectly safe, Jerry, to put 100 without the centimeters squared here, and the 70 without the centimeters squared. We accept that in mathematical subjects. We are going to write the centimeters squared at the end, showing that we know what our units should be. The correct answer is option C. How long will it take Little Red Riding Hood to skip to Grandma's house? 1,500 meters away at 1.5 kilometers per hour. The first problem that we have is that the distance is given in meter and the speed is given in kilometer per hour. We need to convert 1,500 meter to kilometer by using the relationship 1,000 meter is equal to 1 kilometer. Therefore, what do? We need to divide 1,500 by 1,000. This is reducing the value of 1,500 by 3 decimal places. And we are going to do that very quickly. Let's go, Jerry. Okay. So we have reduced the value by 3 places of decimal. The zeros that appear after the decimal point may be discarded. The distance is 1.5 kilometers. The unit of speed is kilometer per hour. This may be written as kilometer over hour, and it means kilometer divided by hour. So speed implies kilometer over hour, right? That is what speed is given in. So kilometer is a unit of distance and hour is a unit of time. Substituting the quantities in the expression, we get the speed is equal to distance over time. Okay? So what we have done first is that we have converted the 1,500 meter to kilometer. And we have what? 1.5 kilometer. But we need to determine what? The time, which is how long it took Red Riding Hood to skip to Grandma's house 1,500 meters away. So we are going to determine the time that was taken. The zeros that appear after the decimal point may be discarded, as we have done before. And we have here, speed is equal to distance over time. We may derive a formula that may be used to determine the time that Red Riding Hood spent. So if we are going to find time, the time is in the denominator right here. We are going to transpose time to the left hand side. We are dividing by time here. So because we are dividing by time, we have to do the opposite of dividing by time, which is multiplied by time. So we are going to take the time here, transpose it here. The opposite of division is multiplication, so time will be multiplied by speed on the left hand side. So what we really want is time all by itself on the left hand side. It is being multiplied by speed on the right hand side. We will transpose speed to the right hand side by division. So now here we have the right hand side divided by time. To get time to the left, we multiplied speed by time. So the opposite of division is multiplication, so we multiply by time on the left hand side. Speed multiplied by time is equal to distance. Now we need time all by itself on the left hand side. So we need to get rid of speed. If we are multiplying by speed on this side, what do we do on the other side? We are dividing by speed on the other side. So time is equal to distance over speed. So we are taking a look. The speed is 1.5 kilometer per hour and the distance is 1.5 kilometer. So we are going to put the distance 1.5 kilometer here and the speed 1.5 kilometer per hour right there. Any number divided by itself is equal to 1. The correct answer is option D. If a problem were to be realistic, students should be able to pick out the correct answer without making any calculations. A journey for a Little Red Riding Hood that lasts 10 hours would have been outrageous, much more 225 or even 2,250 hours. Right, Jerry? Jerry saying that is not going to be quite outrageous, because if Red Riding Hood had an encounter with the big bad wolf, then she would take even a longer period or may not make it at all. That's a joke that is very corny, Jerry, and that's not mathematical in the least. So we will not even bother to consider Jerry's option at this time. What type of triangle has all angles measuring the same? Option A, an equilateral triangle has 3 equal sides. As a result of this, all of the angles are equal. So an equilateral triangle has 3 equal sides, and the angles are therefore all equal. So this represents our correct answer. So that is the triangle that has what? All angles measuring the same, an equilateral triangle. A scalene triangle has all sides different in length. As a result of this, all angles of a scalene triangle are different in size. In option C, we have isosceles. An isosceles triangle has a pair of equal sides. This results in a pair of equal angles. An equilateral triangle is also isosceles because with all sides equal, we are sure that at least 2 of them must be equal. So, an equilateral triangle must be first isosceles, right? Good. Option D, a right angled triangle has one angle equal to 90 degrees. A right angled triangle may be scalene with no 2 angles equal, or it may be isosceles. In a right angled isosceles triangle, each of the other 2 angles is equal to 45 degrees. See, right angle is 90 and the other 2 angles 45 degrees each. That is going to be equal to 180, which is the angle that is represented by total angles inside of a triangle. If n minus 256 is equal to 4, what is n? So let us write the equation. So we have the same equation right there. We are subtracting 256 from the left hand side. We therefore need to add 256 to the right hand side. Of course, when solving an equation, we need, say the unknown is n, we need to have the unknown on one side all by itself, preferably the left hand side. In so doing, we need to eliminate those terms or those numbers that do not contain the unknown. In our elimination process, we need to do the opposite of the operation that we have. Therefore, the operation that we have here is subtraction. So, in eliminating the 256, we will have to do the opposite of subtraction, which is addition. So we need to add 256 to the other side. So n is equal to 4 plus 256, and that is equal to 260. So n is equal to 260. The answer is option D. If O is the center of the circle, which will give the length of the line segment BC. The line segment BC is a chord because it goes between 2 points on the circumference of a circle. A chord goes between 2 points on the circumference of a circle. See, this is on the circumference, this is on the circumference. It is, however, a chord of a special kind, because it passes through the center of the circle, it is called a diameter. So then BC is a diameter. The line segment OA, OC, and OB are all radii of the circle. A radius of a circle is a line segment that goes from one point on the circumference to its center, or vice versa. So, because of this, a diameter of a circle is always twice the radius of the circle. So, the diameter goes from circumference to circumference through the center. And the radius always goes from the circumference to the center, or from the center to the circumference. Therefore, the diameter is always going to be twice the radius. That's we have right there. So what is the diameter? The diameter is BC, and the radius, any one of these would be the radius. So BC is a diameter and OA is a radius. We may substitute them in the expression. So the diameter is BC and the radius is OA. So BC is equal to 2 times OA. And of course, multiplication is commutative, meaning that the order in which we multiply numbers does not affect the result. Therefore, we have 2 multiplied by OA right there. We may as well write that as OA multiplied by 2. The correct answer is option D. The diagram represents a rectangle divided into many sections. What type of angle is AOF? So let us first highlight the angle AOF. AOF. So let us use our angle cycle to see in which region the angle will fall. So this is our angle. That's our angle AOF. So start at 0. Right. So that is 90 degrees. 90 degrees. Notice at this angle. Notice. And this angle is 90 degrees. So any angle in this region between 0 to 90 degrees is in the acute region. The angle is definitely larger than the one indicated on the angle cycle. It is not acute. Notice that this angle is larger than this one. So this one is in the acute region. So this angle is not acute because it is larger than the angles in the acute region. The obtuse region. Where is the obtuse region? The angle is between 90 degrees and 180 degrees. It is therefore in our obtuse region. It is obtuse. So the angle that we are looking at is an obtuse angle. The correct answer is option A. How do we know an obtuse angle? The angle is between 90 degrees and 180 degrees. Which line segment is parallel to BF? So which line segment is parallel to BF? Where is BF? Let us take a look at the line segment BF. That's it. That's our line segment BF. Which one is parallel? What do we mean by parallel? Any line segment that is parallel to BF will go in exactly the same direction as BF. This means that if the lines are continued indefinitely, they will never meet. So if we are going to look for lines that if we go, they will go in the same direction as BF, or they will continue in the same direction indefinitely, they will never meet. So which lines will be parallel to BF? So we have 2 lines that are parallel to BF, AG and CE, because if they continue indefinitely, they will never meet. BF, CE, and AG are all parallel. There are two lines that go in exactly the same direction as BF. They are AG and CE. The one that is represented in the options is AG. The correct answer is option D. Although CE is also parallel, it is not among the options. Only AG is among the options, so that represents our correct answer.